Hello everyone. Welcome to the next lecture on the real analysis part C solution. Myself Dr. Harish. You can follow my YouTube channel where you can find the complete solution of the CSIR NET July 2025. All these videos are explained with the help of the shortcut tricks. I hope you can follow and subscribe my YouTube channel. Now let's start with the first question. If you closely look about the first statement, your target is to find the limit of the Sn and limit of the Tn. Fine. Now if you read the statement, what is the limit of the Sn? If you take the limit as n approaches infinity, that number will be 0 to infinity 1 over k factorial square. As we all know, whenever n is my positive integers, fine, as you can see, k varies from 0 to is a positive integer, n square is always be greater than of the n, or you can also say the 1 over n square is always be less than of 1 over n. I can replace the n to be k factorial. Fine, मैं ये लिख सकता हूँ easily. Fine. Now you can take the summation as k varies from 0 to infinity. Fine. The left hand side becomes limit of the Sn as n approaches infinity, which is less than equal to, what is that series? If you open them, it is a 1 plus 1 over 2 factorial, 1 plus 1 over 1 factorial and so on. This is nothing but e raised to power x, and x is my 1. Therefore, limit of the Sn is my e. That means the limit is bounded above by e. That means the upper bound must be the e. But if you look about the infimum, that means the infimum is always be less than of the e. Fine. E is my 2.718. You can choose any number which is less than of the 2.718. Let's say 2.717. Is it always be greater than of the e square? No. The third option is cancel. Fine. Now similarly, if you look about the t of n, because the rest options are my t of n, if you take the limit as n approaches infinity, this becomes infinity, k varies from 0, n c k minus 1 raised to power n of the k. Now which things come in your mind when you look about the n c k? If you look about that, if I write as a n c x, it is a raised to power x, p raised to power n minus x. That is look like, say, yes, it's a binomial. So you can write as a plus p raised to power n. So this quantity is nothing but, I can write what is the a and what is the p. I can write the quantity is 1 into n minus k also. Therefore, this number is fine. Now you can take the limit as n approaches infinity. Once you take the limit as n approaches infinity, this number is my 1 over e. Now because this number is my equality, therefore, what is the limit of the infimum? Limit of the infimum, limit of the supremum, both are same and they must be 1 over e. Now look at the options. The fourth option say 1 over e is greater than of the e. That's wrong. Limit of the supremum, 1 over e is less than of the e. That's a fine statement. Limit, again this number is my less than of the e. Fine. 1 over e is less than equal to e. That's a fine statement. A and B are the right answer of the problem. Look at the second one. The limit of the, that's a very simple question. I think that everybody have corrected it. You can use the Cauchy's second theorem of the limit. What is the Cauchy's second theorem of the limit? Limit an raised to power 1 over n as n approaches infinity, it is equal to limit n approaches infinity an plus 1 over an, provided, yes, anybody know what is the condition? Provided the limit is my finite. Fine. Provided the limit of this expression must be finite. Now you can see your target is to write the value in terms of an raised to power 1 over n. Can you write the quantity in terms of power 1 over n? So I can write this number is n raised to power n. Fine. Therefore, you can say an will be n plus 1, n plus 2 up to the 2n divided by n raised to power n. Now let's start with the an plus 1 over n, or firstly I can calculate the an plus 1. That number is n plus 2, n plus 3, and the last number is 2n plus 2 divided by n plus 1 raised to power n plus 1. You can see if you divide them, n plus 2 will be cancelled, n plus 3 will be cancelled, 2n and 2n will be cancelled. So an plus 1, that number will be 2n plus 1. इसके पीछे 2n plus 1 रहेगा एक. Then 2n plus 2 divided by n plus 1 raised to power n plus 1 divided by a of n. an में क्या बच गया आपका? n plus 1 raised to power n. Fine. You can see I can cancel this value. The expression is a 2. I can multiply them. It's a 4n plus 2 n plus 1 और इन दोनों को combine कर लेता हूँ. Fine. n over n plus 1. Now you can take the limit as n approaches infinity. If you take the limit as n approaches infinity, I can write this expression is 1 over 1 plus 1 over n. So when you take the limit as n approaches infinity, this number is 4. This number is my e. 4 over e is the right answer of the problem. But because this is the part C, so it may have more than one correct options. We can see about the third option. I can write 2 as a log to the base e. Fine. I can write this number is log of e 2 over e, which is not equal to 4 over e. So third option cancel. I can write for the fourth option. I can write this number is log of e of 4 minus log of e of e. Again, I can write this number is log of e 4 by e, which is not equal to 4 over e. So fourth option is also cancelled. Right option is only the second option is the correct answers. I hope student you can like and comment on this video as well. Okay, fn is a sequence of the real valued function on the R. Which of the following statements are my true? It's a very simple question. If you already watch my lecture on the sequences of the functions, then you can easily discard and get the correct options easily. Look at the first part is fn converges to the f uniformly. Fine. And fn is given to be uniform continuous. Because the function is my uniform convergence, f must be uniform continuous. So yes, the first option is the correct answer. अगर यहाँ पे point wise होता, then it may or may not be. Fine. Look at the second option. fn converges to the f point wise. Fine. Such that fn is my bounded. fn is my bounded. Then can you say f is bounded? No. ये कब true होगा? If instead of the pointwise, if it is written as a uniform, then it's a correct answer. But because it's a pointwise, this option is the wrong answer. Fine. And you can simply choose it as a function. fn is a bounded. Each of the fn is my bounded. You can simply choose as a series. You can simply choose as a sequence. 0 to n. Fine. I can write as a it's a GP. So a 1 minus xn over 1 minus x, and I can choose an axis lies between 0 and 1. Then clearly say f, what is the limit as n approaches infinity? It is 1 over 1 minus x. Clearly say the function is my bounded on the interval 0, 1, but this function is my unbounded on the closed interval 0, 1. So that means the second option is the wrong answer. Look at the third option. fn converges pointwise. fn converges to f pointwise. fn is my bounded and continuous. Then you can say f is also bounded and continuous. Can you say fn converges to the f uniformly? That's a wrong, because pointwise doesn't implies the uniform convergence. Uniform convergence implies the pointwise convergence. Fine. Or example, again you can choose an as an example. Say fn is x raised to power x, x raised to power n, which is a continuous. Every polynomial is a continuous. It is a bounded on the closed interval, and if you calculate the limit, if x is 0, limit is 0. If x is 1, limit is 1. If x is lies between 0 and 1, answer is 0. Now clearly say this function is not continuous. Although it is a bounded, but it is not continuous. So once the function is not continuous, if this function is my not continuous, fine, then it means it is not uniform convergence. Fine. Now look at the fourth options. Fn converges to the f uniformly, and it is given that Fn is my differentiable. Can you say f is my differentiable? No. Why? Because the result is if Fn prime converges to the f prime uniformly, then only you can say differentiability implies differentiability. But here Fn converges to the f uniformly. So the answer is A is the right answer of the problem. Is it okay? Another way, you can discard the second option by using this counter example, because we need a bounded. So I can choose this function is my bounded. Fine. I can choose say 0, 1. Is it bounded function? Fine. Is it a point Fn? Now you can calculate the limit. What will happen if x is equal to 0? If x is 0, it is my infinity. Fine. Limit as n approaches. Whenever x is equal to 1, the answer is 1. Whenever x is lies between 0 and 1, this number is my again infinity. Clearly say this is my unbounded. Fine. So again you can see f is my unbounded is not the right answer. But for that case you have to compute the limit firstly, whether it's a pointwise or not. Fine. So this example is not applicable because it's not a pointwise. Chaliye, look at this another one. F is my bounded. Mod of f is less than of the m. Continuously second derivative is greater than 0. कोई ऐसे फंक्शन सोच सकते हो आप जो बाउंडेड भी हो. एवरी कांस्टेंट फंक्शन इज माय बाउंडेड. फाइन. पोलिनोमियल नो, बट इस डोमेन के अंदर पोलिनोमियल बाउंडेड नहीं है. फाइन. साइन एक्स इज इट बाउंडेड? यस, बट इसका सेकंड डेरिवेटिव ग्रेटर देन 0 नहीं मिलेगा आपको. फाइन. इज इट ओके? सो पहले फंक्शन इफ f इज इक्वल टू 1, then clearly say f double dash is my greater than 0. Satisfied? So look at that. Then f dash is my 0. So satisfied? Again satisfied? This option is wrong, because limit x into 0 is my 0. He said need not exist, but this limit is my existence. x into 0 is 0. So एक option तो discard हो गया. Fine. Now what is the meaning of the f double dash is greater than 0? Can I say the f dash is my increasing function? Because किसी भी चीज को इंक्रीजिंग कब कहोगे? जब उसका डेरिवेटिव ग्रेटर देन 0 होता है आपका. फाइन. तो यहाँ पे सेकंड डेरिवेटिव ग्रेटर देन 0 है, दैट मीन्स f is my increasing. Fine. Now once f is increasing, what will happen? Because my domain is 0 to infinity, so there are the three cases. Case 1, case 2 and case 3. F is increasing. It may possible the graph is increasing like this way. That means at the initial value it is my positive and then 0. Second is it start from the lower value. Fine, because it's the open interval. So it start from the negative and then it's increasing. Or third is where it's a up to here. Fine. So if I consider the three case A, B and C. Now your target is to find the limit as x approaches infinity. We all know the relation between the fx at x naught plus x into x naught is f dash. यही होता है ना लिमिट. Now let's say what will happen if you take, I will check limit of this case. Assume that first case occurs. That means whenever x approaches infinity, f dash is my positive. Whenever f dash is my positive, that means this quantity, whenever x approaches infinity, this number will goes to the infinity. Fine. Because आप इसको ऐसा भी तो लिख सकते हो ना. I can write for you here. Fine. So let's say limit of the f dash is my L. Say. Fine. तो ये नंबर L हो जाएगा आपका. Then you can say f of x naught plus L is outside x minus x naught. Fine. Whenever this limit L is my at the point infinity is my finite, is a positive, then whenever x approaches infinity, this number is infinity. Once f is approaches infinity, that means the function is unbounded. पर लेकिन फंक्शन तो आपको बाउंडेड दिया है, इसका मतलब ये केस पॉसिबल नहीं है. फाइन. Similarly for this case also, whenever x approaches infinity, the number is positive. Again this number is my unbounded. Second option is also not possible. Third case, what will happen whenever x approaches infinity? It's a 0. Whenever f dash is 0, it is a constant function. So that's true. Fine. So that means this is the case occurrence of the f dash. This is the behavior of the f dash. Can you find the nature of the f dash? You can see f dash is always less than 0. So first option is the right answer. Is it okay? Now look at the second case. What is the limit? If I choose the limit is my L, if L is my positive, then this limit will be infinity, which is unbounded. If L is my less than 0, that is a negative. If L is my negative, then this number will approaches toward the minus of infinity. Again, this is unbounded. So that means both the options are cancelled. Only option left behind is second is the right answer. Now, third option, x into f dash. Now we can see that f dash is always be less than 0. Fine. And I can choose the f dash is my minus 1 over x raised to power say a, where a is my greater than 1. Fine. ऐसे ही कुछ होगा. Then you can choose x into f dash. It will be minus 1 over x raised to power a minus 1. A minus 1 is my greater than 0. And when you take the limit x approaches infinity, this number will approaches toward the 0. Yes, the fourth option is the right answer. So 1, 2 and 4 are my right answer of the problem. Okay, look at this another one. A sequence of the functions fn converges to the 0, fn dash. तो पहले fn dash में निकाल लेते हैं. So can you find the derivative with respect to x? So it will be e raised to power minus x square n square into 2n square x divided by n. So n and n will be cancelled. Minus 2nx e raised to power minus n square x square. Okay, सबसे पहले point wise check करना पड़ेगा. Fine. So if you choose the point wise convergence of the fn, तो क्या आंसर आएगा इसका? You have two cases. If x is 0, if x is non-zero, because you are defining on the r. If x is my 0, this is e raised to power 1. So the limit is 1 over n. 1 over n limit is my 0. Whenever x is my non-zero, I can write this quantity is e raised to power minus, and again it goes to the 0 as n approaches. So that means fn converges to the 0 pointwise. Is it okay? So converges does not, but it's f dash converges pointwise. Now you can check about the uniform convergence. I can take the supremum of the x, fnx minus f. Because f is my 0, I can take an fnx is e raised to power minus x square n square divided by n over x belongs to the r. Now when it will be the maximum? Clearly say because of this negative, this number will be maximum when x is my minimum, or x square will be my minimum. When x square will be minimum? X square will be minimum when x will be 0. So add the x equal to 0, this limit will be 1 over n and it goes to the 0. Therefore, fn converges to the f uniformly. Fine. The last option, not uniformly, cancel. Converges uniformly to the 0, fine. Converges uniformly 0, fine. Now you have to check about the differentiability. So can you find the limit pointwise convergence of the fn dash? Again, you can check about if x is equal to 0 and if x is non-zero. If x is 0, the limit will be 0. If x is non-zero, then it will be n over e raised to power n square x square. Clearly say when n approaches infinity, it goes to the 0. ये infinity by infinity हो जाएगा ना, आप L'Hopital rule लगा लेना बाद में, तब भी 0 ही जाएगा. That means fn dash converges to the 0 pointwise. But you can see the third option does not converges pointwise. Fine. चलिए अब फिर से सुप्रीमम लेते हैं फॉर द यूनिफॉर्म कन्वर्जेंस. fn dash 2nx divided by e raised to power n square x square minus 0. x belongs to the r. Fine. अब आप देखिए इस पे तो आप नहीं ना कह सकते कि 0 मिनिमम होगा, बिकॉज ऊपर भी x लिखा हुआ है. तो आप क्या करते हो, हमेशा एक सब सीक्वेंस लेते हो. अगर उस सब सीक्वेंस से ये 0 पे नहीं गया, देन वी कैन से इट इज अ नॉट यूनिफॉर्म कन्वर्जेंस. अगर ये कोई भी सब सीक्वेंस लेके 0 पे चला गया तो हम कुछ नहीं कह सकते. एक सब सीक्वेंस लेते हैं हम 1 over n की. फाइन, तो इस सब सीक्वेंस पे इसकी लिमिट कितनी आ जाएगी, 2 डिवाइडेड बाय ई विच इज नॉट गोस टू दी 0. दैट मीन्स एफ एन डैश इज नॉट यूनिफॉर्म कन्वर्जेंस टू द 0 और एक्स एन की वैल्यू कहां पे जा रही है, ये भी 0 पे जा रही है ऑन एनी इंटरवल which contains 0. Fine. Fn dash is not uniform convergent on any interval which contains 0. Fn dash converges pointwise. Fine. Fn dash converges uniformly, लेकिन इसके बीच में 0 आ जाएगा. So that means the right option is only second is the right answer of the problem. Okay, look at this another one. F and G are the Riemann integrable functions. Which of the following statements are my necessity too? Very simple. If you already watch my Riemann integration lecture, I already tell you the shortcut tricks. What is the shortcut tricks related to the composition? F circles G is said to be the Riemann integrable when, first thing is, if F and G are my Riemann integrable, fine. And second thing is, the first function, that is the F, is my continuous, fine. अब आप देखो फर्स्ट कंडीशन तो सेटिस्फाइड है, एफ एंड जी रीमन है, लेकिन फर्स्ट ऑप्शन में क्या आपको एफ कंटिन्यूस गिवन है? देयर इज नो गिवन दैट एफ इज कंटिन्यूस. इसका मतलब अगर आप एक एफ डिसकंटिन्यूस फंक्शन ले लो जो रीमन इंटीग्रेबल हो, बट इट इज नॉट ए कॉम्पोजिशन, इज नॉट ए रीमन इंटीग्रेबल. और सेकंड लास्ट ऑप्शन में एफ इज माई कंटिन्यूस गिवन, फाइन. चलिए थर्ड ऑप्शन देखते हैं. एफ एंड जी आर रीमन इंटीग्रेबल, fine. That means f square and g square are also Riemann integrable. If f square and g square are Riemann integrable, the sum of the two Riemann integrable is also Riemann integrable. Fine. If f is my Riemann integrable, then root of the f. Firstly, if f is my Riemann integrable, root f is also Riemann integrable if f is my greater than 0. And because it's a positive number and it's a positive square root, therefore f square plus g square is also Riemann integrable. Fine. Now look at the second options. G is my non-zero and f divided by g. Look at that. F and g are Riemann integrable, and we all know f plus g, f minus g are also Riemann integrable. Fine. But the product and the division, it may or may not be Riemann integrable. Fine. So I can easily provide the example. Very simple. I can choose an f is my 1. Fine. इससे आसान हो जाएगा ना f. Then g I can choose an as a discontinuous function. Say 1 over 4. Fine. X belongs to the Q intersection 0,1 और इसकी discontinuity सिंपल आप 0,1 पे ले लेते हैं. Fine. Then clearly say f and g are Riemann integrable. G is my bounded. Fine. F is my bounded. F is a continuous. G is not a continuous at the point 0,1. और इसके अंदर discontinuity कितनी है? Fine. Now can you define as a f over g? What is f over g? It is a 1 and it is 4 when x belongs to the Q and whenever x does not belong to the Q. How many discontinuities are there? The function is discontinuous at everywhere. Fine. And if the function is discontinuous at everywhere, this is uncountable. Moreover, what is the measure of the discontinuity measures? It's always the positive. Fine. Therefore, it is not Riemann integrable. So the second option is cancelled. Third and fourth options are the right answer of the problem. So you can see that all these questions are explained in a very, very simple manner. Again, I can suggest you can watch about my this playlist like of the Riemann integration, bounded variation, improper integral, Mobius transformations, many more lecture available in this playlist free of cost. I will upload the next lecture on the linear algebra part C solutions. Till then, you can share this video with your friends. You can like and comment on this video. Happy learning always. Best wishes.